Second part of rational expressions. I know, it feels like my own radio program. It's so exciting. All right, if you want to do the next problem, I think y'all are off on a roll, if I'm not mistaken. Everything seems really good, except for the range. That's the hard part. So I'll go and catch up with you because you probably did all these things a long time ago. You're going, hey, what's my horizontal asymptote? It's top heavy, so I didn't have one. But it doesn't mean there's not some weird behavior at the end. It's called, in this case, a slant asymptote. When it's top heavy, it can have quadratic asymptotic behavior. What we do when it's top heavy is long divide to determine what the end behavior is. The quotient actually tells us that. And then you go vertical asymptote, anything that makes the denominator 0. Sorry for the font issue, but that's actually half x plus 3. So if you set that equal to 0, then you subtract 3 and then multiplied by 2, and you got -6. So domain-wise, x equals -6 is going to give us a vertical asymptote. Congrats, my video's on YouTube. The coincidence is amazing. But the domain then is -infinity then to -6 and -6 to infinity. And if you look at the graph, I think all that is nicely reconciled. There it is, -6. Okay, no hole, nothing to worry about up there. If you factor the top, it doesn't cancel with anything in the bottom. Now, range. Ooh, there's no horizontal asymptote. That doesn't work. So the way we determine range is you realize that this reaches a peak somewhere on the left-hand side and a valley somewhere on the right-hand side. That's the gap we need to account for in our range. Like it's -infinity. Let's call this like, A height. So if I call this like my something comma A, and then this one over here is my something comma B, then I'm missing some gap between A and B. My range goes -infinity to A, and then, but I'm going to just leave it blank. Say, all right, -infinity to something, something, and then it picks up again at something, something, goes on to infinity. The way we're going to find those is actually go to our calculator and find the points of the peak and valley. So there's the equation in the calculator. And if I hit graph, it doesn't look particularly good. But thankfully, you know what you're looking for. Obviously, you need to go a little bit further in. You have actually, the whole problem is graphed for you. So if you notice the window on the one you're given goes pretty low, like y min of -100 or something, I would say. So you go, and I can't see the negative button, so I don't know how I'm going to do that. But I'll just put a 0 on the end. I actually cannot reach the negative button. That's funny. All right. Graph. Yeah. Oh, ooh. There we go. That's nice. And it looks like I need a little more to the left. To the left. To the left. Maybe to the front. Front. Side. Side. Then we can go dip on one side, baby, and dip on the other. There it is. Nice. Yes, there it is. Graph that we have on our picture. So to find that point, you need to know how to find a peak and a valley on your calculator. So if you go second trace, that calc button, you want to go to that maximum when you're looking for a peak. So that means the one on the left. You got to go left, left, left until your cursor kind of lands in the right region. So I go left, 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 left. Left bound means just denote some spot to the left of the peak. Doesn't have to be fancy. Right bound just means get somewhere to the right, somewhere. Doesn't be nothing fancy. And then guess is either try and guess or just hit enter again. It's either one will work. And it says -9, -32. That's the point. So when I look at this graph, I'm actually going to label it in there. If I can get there. -9, -32. I think I'll just erase that. -9, -32. That matches. Looks pretty good. And the other one, we'll come up and get that one in just a second. With the minimum option, so second calc, use the minimum, number 3. And if you're good at this is no big deal, but left bound, okay. You always hit enter. Right bound, all right. Guess, okay. And it looks like 3, -8, and those extra zeros are part of the approximation process. So I'm going to go ahead and plot that point as 3, -8. ish, or negative 3, negative 8. So that helps me because now I know that the height of the lower piece goes to negative 32 and the height of the upper piece is at negative 8. Those are the numbers where my range takes a little leap. So I'm going to use those two to my advantage. So here comes the range. Negative infinity to negative 32. And there's a break. Negative 8 to infinity. So just knowing that range stands for is like a gap in there. If you know what you're looking for, then you just, any way you can find a way to tell what's the highest it gets on the bottom part, lowest on the bottom, on the upper part. That's it. Okay. X-intercept, y equals 0. That means the whole thing equal to 0. And it's, for me, that's my numerator equal to 0. And that's quadratic. We love quadratics equal to 0 because I can factor that. You guys okay with that? That's my numerator equal to 0. That's what I'm, if you don't like that, let me know. Plus 5 minus 3. Good factors. That means we must have negative 5 and 3 are going to be our x-intercepts. And if I look at my picture, hopefully that matches. And I think it does. Negative 5, it crosses, bingo, and over at 3, it's off the charts, but looks promising. Okay. And then finalmente, set x equal to 0 for my y-intercepts. And that means, what do we get? Put zeros in there, negative 15 thirds, and that makes negative 5. And see if it makes sense in your graph. Does it seem to cross at negative 5? I think so. I like it. That's it. We've analyzed those. We have a good sense of where things are. So if you see these rational expressions, we're going to see one here in a minute on the other sheet that we do. You're going to do the same kind of thing. Try and factor them first. I think a couple people are hung up on what to do. That's factorable. Take a common factor x out of there and negative 4. Then you can go, oh, I see. I got a vertical asymptote at 0 and x equals 3. Those are the two illegal values. Horizontal asymptote, it's bottom heavy, so we're looking at y equals 0. And I think all that is nicely placed in the graph. It works. Now the horizontal asymptote is where the graph approaches at extreme values, but look at this big gap though in between them. Got another one of those gap areas. We have to account for that, and all we have to do is do what we just did a minute ago. I'm going to go find the bottom of that with my calculator, find that minimum. And it's 1.5 comma 1.777. I did it just right before your eyes. Did you notice that? It was a flash. But I wanted to speed things up a little bit. Same process. I just did it with my calculator earlier, and I'm loaning it to you, so you don't have to look it up. So that means that height, that's the part I want on that. It's not, when you're doing range, you just don't know where to start, so let's get some purple in there, because I haven't had purple yet. But that 1.7 is that's important in my range. Okay. Just to close this off, negative infinity to 0, and then I went 0 to 3, and there's a break, 3 to infinity. You can be looking at the graph while you do that. I think it's helpful. And then range was negative infinity to 0, and then there's that gap. It doesn't pick up again until, bless you, 1.7 to infinity. X-intercepts when y equals 0. And if I set this numerator equal to 0, the y equal to 0, that ain't going to happen. So there are no x-intercepts. And the y-intercepts is when you put 0 in for x. And this ends up being not so good. That's undefined. And that means there's no y-intercepts either. And I think that matches my graph. I have no zins or yints. Nothing. That's rational functions at its best. I will show you. There's another, the next sheet we do, you guys got handed back your old rational function stuff that we did just for reminder of what we did before. Then you want to get out that review function, this sheet I just handed out. There's a rational function right there, but it's got a radical in it. It's a rational with a radical in it, rad. So your job now is to go try that out. We'll meet up later and I'll record some stuff about it. done with that video.